Welcome back to Neural Intel. Today we're diving deep into a new benchmark in online advertising. Our mission, as always, is to really unpack the technical details and explore what it means for, the future of smarter advertising algorithms. We've got the research right here.
Yeah, and what's fascinating right off the bat is the core problem this benchmark tackles head on. It's the scarcity, the real lack of good comprehensive data for building and testing these auto-bidding algorithms.
Exactly. It's like trying to train a super smart AI with, I don't know, just a handful of examples. Doesn't work well.
Precisely. So a team from Avito and several Russian academic institutions, they developed BA.
BAT, right. BAT benchmark for auto bidding task,
Hmm.
sort of a high fidelity playground for these algorithms.
And what makes BAT really stand out is its data set. It's brand new, pulled directly from the Avito platform, and it covers the two big ones in online auctions. First price,
Where you pay what you bid. Simple enough.
right, and Vickery Clark Groves, VCG.
Yeah.
That one's a bit more intricate, designed to encourage, well, truthful bidding.
And the scale we're talking about here is pretty impressive, isn't it?
Oh, absolutely massive. It's roughly 10 million first price auctions and about a million VCG options.
All gathered in just 1 month.
Just 1 month. So it's a really rich, detailed snapshot of how these ad markets behave in the real world.
And this lets researchers tackle some key problems in real-time bidding.
Exactly. Two main areas jump out. First, budget pacing uniformity, basically making sure a campaign spends its money smoothly over its lifespan, not all at once or too slowly.
Okay, consistent spending. What's the second?
The second is optimizing bids to hit a specific cost per click target, the CPC. Advertisers often have a goal for how much they're willing to pay per click.
Right. And the really interesting part, for me anyway, is that the researchers didn't just release the data.
No, they went further. They
Mhm.
actually built and open sourced a set of baseline algorithms that work directly with this BAT dataset.
That's a huge leg up, isn't it, for anyone wanting to jump in and experiment?
Definitely. It lowers the barrier to entry. And importantly for anyone listening who wants to dig deeper, all of this, the data set, the code, it's all up on GitHub and Zenodo.
We'll have links in the bio, of course. Great resources.
Absolutely. Gold mines, really, for implementation details.
Okay, so that sets the stage for BAT. But maybe before we dissect the data set itself, let's just quickly recap how these online ad auctions actually function. What's happening under the hood?
Well, modern online advertising is incredibly dynamic, right? You visit a website, use an app, and the ads you see. They're often chosen and slotted in right then and there, in real time, tailored to that specific moment.
It's not like a static poster. It's a live marketplace happening constantly.
Exactly. And deciding which ad gets which slot usually comes down to an auction, a super fast competition between advertisers whose ads are relevant at that moment.
And this is where real-time bidding, or RTB, comes in.
Yes, because you've got countless ad slots opening up every second across the web, and decisions need to be made in, like, milliseconds. Humans just can't keep up.
No way. You need algorithms, sophisticated ones.
Absolutely essential. They handle the bidding automatically.
And these algorithms, they need to be reliable, efficient. Basically, they need to deliver a good return on investment for the advertiser.
That's the goal. And research, looks at both VCG and first price auctions because both are common, competitive ways to allocate these ad spaces. Each has its own strategic quirks.
Now, advertisers setting up campaigns, they have specific goals, right? It's not just show my ad everywhere.
Not usually, no. Budget is almost always a major constraint. They'll set a total spend for the campaign duration.
And often targets for things like clicks, or as you mentioned, a maximum cost per click.
Precisely. The target CPC is very common. How much are they willing to pay for each click they get?
Which loops us right back to the start. How do you build algorithms to manage all this complexity without good data to test them on?
And that's the gap BAT aims to fill. It's designed specifically for developing and evaluating these auto-bidding algorithms.
Okay, let's get into the data set itself then. You mentioned it has 3 main parts for both VCG and FP auctions.
That's right, 3 core components: campaigns data, auction statistics data, and traffic data.
Let's start with campaigns. What kind of info is in there? Table 1 in the paper, right?
Yep, Table 1 lays it out. It gives you the static details for each campaign, things like unique IDs, losted for the item's location, campaigned, itemid.
The basic identifiers.
What else? You get the start and end dates, anonymized, of course, and timestamps, campaign start, campaigned. Crucially, the total auction budget.
Budget's key. And info about the ad itself, like what's being sold.
Yeah, there's microcat text for a super specific category and logical category for broader grouping global and subcategory, plus the region where it's offered.
Makes sense. And there was something about different platforms.
Right. It tracks how often the ad participated across 4 different platforms.
Hmm.
The researchers note this could be used as a feature in future algorithms, even though their baselines didn't use it directly.
Interesting potential there. Okay, that covers the campaigns. What about the auction statistics data? Table 2.
So this part is really geared towards simulating auctions and training models. It's separate from any specific bidding logic. Each log line represents one campaign participating in one auction.
Okay, and what are the key fields here?
You've got the usual IDs plus a period timestamp for when the stats were aggregated. A really important one is contact price bin.
The price bin, how does that work?
It's a discrete value representing the bid price. There's a formula, a logarithmic one, to map it back to the actual bid amount. It helps structure the bid data.
Got it. Sort of simplifies analyzing bid levels. What else?
Then you have these surplus fields. Auction win bid surplus estimates the extra cost if you bid a bit higher and won. Auction visibility surplus estimates the extra visibility from bidding higher.
Ah, okay. So the expected gain or cost from adjusting your bid slightly.
Exactly. Vital for decision making. There's also auction clicks surplus and auction contacts surplus, the expected extra clicks or contacts from a higher bid.
And predictions.
Yes, aggregated CTR predicts click-through rate and CR predicts conversion rate for the item. And finally, auction count for VCG, showing how many auctions contributed to these stats.
Okay, that gives a pretty detailed picture of potential auction outcomes. What about the third piece, the traffic data?
The traffic data, that's Table 3 and Figure 1 in the paper. It shows how user activity, measured by contacts, ebbs and flows on the platform over time.
Broken down by region and time?
Yep, by region, day of the week,
Yeah.
DAO, and hour. And the key metric is traffic share. What portion of the total weekly contacts in that region happen at that specific day and hour?
And Figure 1 really shows massive swings.
Well, huge, like a 30-fold difference between peak traffic around noon and the dead zone around 3 a.m., plus clear weekly patterns. Monday's typically busiest, Saturday's slowest.
Seems incredibly useful for pacing bids. You wouldn't bid the same at 3 a.m. as you would at lunchtime.
Exactly. Algorithms can use this to anticipate activity levels and adjust their strategy. Be more aggressive when traffic is high, maybe pull back when it's low.
So BAT sounds way more comprehensive than older data sets. The paper mentions IPINU.
Right, the 2014 IPNU data set. It was important then, but had limitations. Only 9 advertisers, so hard to study competition.
Huh.
All second price auctions, which isn't the whole picture anymore. And, well, it's a decade old now.
Technology moves fast. What about the Alibaba one from 2024?
That one's focused on reinforcement learning for RTB, especially with cost per action goals. Uses generalized second price auctions. Great for RL research, but again, fewer advertisers than BAT.
So what are BAT's main advantages then? Sum it up for us.
Okay, key advantages. Way more advertisers, over 9,000. Huge auction volume, over 10 million. Includes those aggregated CTR and CVR predictions. And crucially, data for both VCG and first price auctions.
That dual auction support seems vital now, with first price becoming more common.
Absolutely. Plus, the researchers say BAT's format is very close to what large platforms actually use internally. That suggests algorithms proven on BA might translate well to production systems. The range of predictions is also really wide, which is good for testing robust strategies.
Okay, fantastic data set. Now, what did the researchers do with it? They tested some baseline algorithms, right? Let's get into those technical approaches.
Right. They implemented and tested 5 main baselines: adaptive linear model, ALM, traffic-aware PID, TAPID, a modified model predicted PID, MPID, Mystique, and BROI. Each tackles budget pacing or CPC control a bit differently.
Let's break them down. ALM, adaptive linear model. What's its angle?
ALM is the straightforward one. It basically predicts future spending based on past spending and remaining time, assuming a linear trend. Then it adjusts the bid proportionally. Simple, computationally cheap.
Okay, a basic linear approach. What about TAPID? That's traffic-aware PID controller.
Yeah, PID controllers are common in engineering. TAPID uses one to adjust the bid based on the difference between the desired spending rate and the actual rate. The traffic-aware part means it factors in that historical traffic data we talked about.
So it's trying to stay on the spending target while also considering expected user activity levels. Makes sense. Then MPID, model predictive PID, modified. How's it different?
MPID also uses PID control, but sets specific reference signals for both budget spending and target CPC. The key modification here is normalizing the budget spend based on the remaining expected traffic. Aims for smoother spending relative to opportunity.
Okay, a bit more sophisticated. And Mystique.
Mystique's goal is pure linearity in budget spend over the campaign's life. If it's over or underspending compared to that straight line, it adjusts the bid to get back on track. The version here focuses just on bid control based on that linearity goal.
Right, linear spend focus. Finally, BROI, budget ROI.
Exactly. ROI here is interpreted as a CPC constraint. BROI has some theoretical grounding in auction dynamics,
Yeah.
designed to be stable even if many advertisers use similar strategies. They used what they call an optimistic variant here.
Okay, 5 distinct approaches. How did they test them? What were the experiments?
3 main experiments. First, budget pacing. They tested ALM, TAPID, MPID, and Mystique on how well they kept spending uniform, normalized by traffic share. Metric was RMSE, root mean squared error lower is better, plus SCR, sum-click ratio for efficiency.
So how smooth was the spending? Got it. Second experiment.
CPC constrained. This focused on MPID and BROI. They gave them a really tough CPC target 10 times lower than the category average and measured how well they hit it using relative cost per click, REL CPC.
Testing the cost control aspect. And the third one.
Click maximization. Here, they basically removed the CPC constraint for all 5 algorithms by setting it super high. Then they just compared the sum click ratios, SCR, to see which algorithm could grab the most clicks for the budget.
Pure click efficiency. Okay, seems thorough. How did they run these? Simulation details.
They simulated using both VCG and FP data from BAT. Algorithms recalculated bids hourly. Budget was reduced based on expected costs, using those aggregated CTR-CVR predictions from the dataset to estimate contacts, clicks, and costs at different bid levels.
And they used the platform's expected price calculations for budget reduction in VCG and FP.
Yes, based on expected contacts times bid for FP and the sum of expected incremental costs for VCG. And importantly, they split the campaign data training set, S1, validation set, S2. They tuned algorithm hyperparameters, using Bayesian optimization Optuna on S1, then reported final results on S2.
Smart tuning. Okay, the results. What did they find? Let's stick to logical category 1 as in the main tables.
Right. For budget pacing, Table 6, Mystique generally had the lowest RMSE, meaning the smoothest spending, on both VCG and FP. Makes sense given its design. MPID was second best on FP, TAPID second best on VCG. ALM struggled a bit more, especially on DCG.
So Mystique wins on smoothness. What about hitting that tough CPC target, MPID versus BROI?
Table 7 shows MPID did much better on REL CPC in first price auctions than VCG, so it hit the target more effectively in FP.
BROI was more consistent across both auction types, but didn't get quite as low as MPID and FP.
Interesting difference between auction types there and for just raw click maximization. Table 8. Here, TAPID and ALM often came out on top with the highest SCR. So they were very efficient click getters when cost wasn't the main constraint. MPID also did well on FP clicks. Mystique did well on VCG clicks.
Fascinating how different algorithms excel at different things. Strengths and weaknesses depending on the goal and the environment. Did campaign duration matter?
Yes, they looked at that too. Table 10 in the appendix. It suggests performance varies. ALM seemed okay for very short campaigns. The PID controllers, TAPID and MPID, often did better on longer campaigns where they could adapt more. Mystique also looked good for very short runs, under 24 hours.
Good context. So wrapping this up, what are the big picture takeaways from BAA?
Well, the main thing is BAD is a really valuable new resource, a large, realistic data set covering both major auction types with detailed traffic and campaign info. It fills a real need in the research community.
And the open source baseline algorithms are a huge plus too.
Absolutely. They provide a solid starting point, a benchmark to compare against. The experiments show how different strategies perform on key tasks like budget pacing and CPC control. It sets a foundation.
And the transparency of those baselines helps too, right? Understanding why they behave certain ways.
Exactly. You can see how things like traffic changes affected their bidding.
Yeah.
Having this benchmark from a modern platform available publicly, it could really help push the science forward, help create better, smarter bidding algorithms.
So for you, the listener, if this technical side of ad tech and ML is your thing, definitely check out the B2 resources. GitHub, Zenodo links are in the bio. Dive in, see the data, the code, think about what you could build on this.
Yeah, and maybe a final thought to leave you with. Given all this detailed data in BTT on BT, the auction dynamics, the traffic patterns, What other kinds of machine learning, maybe beyond these baselines, could really unlock even more efficiency or better performance in these complex systems? Lots of exciting possibilities there.